Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you how to find the graph of a function using its derivative. So a graph is going to be given to you and the question is going to ask you to find the graph of its derivative. Okay, and you won't be given the equation or anything, you're just going to look at the graph. You're just going to look at a graph like this and it's going to give you options. Graph 1, graph 2, graph 3, and you need to be able to tell me which of these graphs is the derivative of this graph. Okay, so in this video, I'm going to teach you how Q can do that. So the way I like to do it is because I had a test recently, and in my test, a question like this was there. So what I like to do is I like to look at where the slope is going to be 0. So in this function, at the extreme corners, the slope is 0 in these corners. So the slope here is 0, the slope here is 0. So find the point at where the slope is 0. So since it intersects the x-axis at 2, the half of that is 1. That means when x equals -1, the slope is 0. Okay, I'm going to write that. Okay, when x is -1, the slope is 0. Okay, and here the slope is also 0, and here it's +2. So the half of that is just +1. So when x equals just 1, the slope is 0. Okay, 1 second. Okay, so when x equals +1, the slope is 0. And you can tell just by looking at this graph that the power of this graph is going to be to the power of 3. So let's say, for example, this graph is x cubed, which is obviously not, but just I'm telling you a trick. If the equation for this graph is x cubed, the derivative of it is going to be 3x squared. That means when you look at your options, you're going to pick the graph that is to the power of 2. Is this graph to the power of 2? Nope. Is this graph to the power of 2? Yes, it is. Is this graph to the power of 2? No, it's not. So directly we can tell which graph is going to be the graph of our derivative, but you could be given a question where there's two of the same squared graphs and you're going to look at the points and find where the slope is 0. So we looked at the graph and we saw that the slope is 0 when x equals -1 and when x equals 1. So we can go back and check. Where is it 0? See, when x equals -1, the slope is 0, okay? When x equals +1, the slope is 0. Okay, so that proves that this is our graph. Okay, that's how I like to do it in my test. So I'm going to show you one more example. Okay guys, so let's say we are given this graph. Automatically from looking at it, you can tell that this graph is going to be to the power of 4. Okay, so let's start by putting it to the power of 4. This is obviously not the equation, this is just to visualize what the derivative graph will look like. So this is going to be x to the power of 4, this graph. So we're going to take the derivative and see what the power will be then. So 4x cubed. Now looking at the options, we're going to pick the graph that is cubic. Okay? This is clearly not cubic, so this can't be our answer. This graph is squared, this can't be our answer. This is a possibility. It could be our graph because it's to the power of 3. Now on the test, if you were given graphs that were to the same degree, to the same power of 3, except they're intersects and everything, they were different, that's when you were going to use the slope. So find the point at where the slopes are 0. Here we have 3 places where our slopes are 0. So it intersects at 2, the half of it is going to be -1. Then intersects at 2, half of it is going to be +1. And this is at 0, 0. Okay, so our slope is going to be 0 when x equals -1. I'm writing with my left hand, excuse my writing. Okay, and when x equals 0, our slope is 0. And when x equals positive 1, our slope is 0. Now that we have the places where our slope is 0, let's verify it on our derivative graph. So is the slope 0 when x equals -1? Let's check. Yep, it's 0 when x is -1. Is the slope 0 when x is 0? Yes, it's 0. And is the slope 0 when x is +1? Yes, it's 0. So it fulfills both conditions. The derivative of the graph is going to be to the power of 3. It's going to be cubic, so yes, it's cubic. And do the 0 slopes match? Yes, they match. So it meets all the conditions, meaning graph number 3 is the graph of our derivative function. Okay. Okay guys, so that's it for today's video. I wanted to keep it short because this question came on my test and I thought it would be important to let you guys know how I did it. So my method might not work for everyone, but this is what worked for me. So please let me know if you understood, and if you have any questions, then also let me know. So yeah, that's all for today. See you guys next time.